Hi students, in this video we're going to cover lesson 5.1, which is parts of congruent triangles. So let's get started. Our objectives are to define congruent triangles, identify corresponding sides of congruent triangles, identify corresponding angles of congruent triangles, and write a congruency statement. And of course, we're also going to solve some algebraic problems that use this new information. So what are congruent triangles? They are triangles that have the same side lengths and the same three angle measures. They have the same three side lengths and the same three angle measures. The or is not or because we'll see that triangles can have the same three angles and not actually be congruent. Congruent means same size and same shape. So in this first diagram, we have triangle ABC and triangle PQR. Notice that all three sides are congruent. So the way we indicate that sides are congruent is by the number of markings that they have. So we're going to put one mark for the 4, another mark for this 4. We have a side that's 4.5, so we're going to put 2 marks. And we have a side that's 5, and we're going to put 3 marks for that. So we have 3 different side lengths for each triangle, and they're paired up. So we have 3 congruent sides. In the second diagram, we have the same triangle, basically the same triangle repeated. We have an angle that's 77 degrees. So we're going to mark that angle congruent to this angle. The angle that's 41, we're going to put 2 arcs to indicate that it's congruent to this other angle. And the angle that's 62, we're going to put 3 arcs. And I suppose across from that, we can put 3 lines for the 4.6, 2 lines for the 3.4, and 1 line for the 5.1. So anywhere we see things with the same number of markings, that indicates that they're congruent. So in this last one, we have a small triangle that's TXE and a larger triangle that's WSA. These are not congruent. So these are not congruent because they just have the same 3 angles. And similar triangles have all 3 angles that are the same, but their sizes could be different. It should be pretty clear that this triangle is the smaller triangle. And so they don't have the same 3, I can spell larger, LARGER. I got that. All right. So again, for triangles to be congruent, they have to have the same 3 side lengths and the same 3 angle measures, not or. As long as we have the same 3 side lengths, the triangle will be congruent. So let's see, a congruency statement. It tells us the angles that are congruent and the segments that are also congruent, or the sides that are congruent. So the order matters. Looking at this congruency statement, we should know that angle W is congruent to angle D. We know that angle X is congruent to angle E, and we know that angle Y is congruent to angle F. So let's mark that. We know angle W is congruent to angle D. We know angle X is congruent to angle E. And we know angle Y is congruent to angle F. Also, the letters, the order of the letters. So the first 2 letters here are going to make a segment, and the first 2 letters here are going to make a segment. So we know that segment WD, I'm sorry, I messed that up. That should be WX, excuse me. So we know that segment WX is congruent to segment DE. We know the last 2 letters, which would be X and Y for the first one. So we know segment XY is congruent to segment EF. And the last one is we need to use the first and the third letter. So we know that WY is congruent to segment DF, or side DF. So let's see, we have WX is congruent to DE. We have FE is congruent to YX. So FE is congruent to YX. And so the last one is going to be YW and FD. So that's how we make a congruency statement. The order of the letters does matter because it tells you what angles and what segments are congruent to each other. So that's how we write it. So for this example, we want to write, like, you pause the video and write the congruent angles and the congruent sides just based on the congruency statement. All right, so if you're rejoining me, you should have gotten that angle A is congruent to angle X. You should have gotten angle B is congruent to angle Y. You should have gotten angle C is congruent to angle Z. That takes care of our three angles. For our sides, you should have gotten side AB is congruent to side XY. You should have gotten side BC is congruent to side YZ, and you should have gotten side AC is congruent to side XZ. Again, just the orders of the letters and how you group them does matter. You should have gotten those 6 things. Next example is in a triangle. So we know that triangle STP is congruent to triangle CRY. And we know that the measure of angle R is 72 degrees. We know that measure of angle P is 43 degrees. And we need to find the other 4 missing angles. So let's draw some triangles. They don't have to be perfect or draw on this scale. We just need some triangles that we can see. So we'll call this triangle, we'll call it S, T, and P. And we need another triangle that we're going to call triangle C, R, and Y. So we know that angle R is 72 degrees. So that's 72 degrees. We know that angle P is 43 degrees. And so because we know that the 2 triangles are congruent, we know angle S is congruent to angle C. And we know that angle T is congruent to angle R. So that means that angle T is also, we're going to put 72 degrees. So angle T is also 72 degrees. So we need to find the other 4 angles. Since angle P is congruent to angle Y, we know that angle Y is also 43 degrees. So now that means the measure of angle S is equal to 180 minus 43 minus 72, that's 115. So 180 minus 115 is 65 degrees. So angle S is 65 degrees. That means that angle C is also 65 degrees. So we found, we needed to find S, T, Y, and C. And so we found all of those angles. We got 65, 72, 43. And we, again, used the congruency statement to help us out with that. Example 3 is you write a congruency statement given this diagram. Remember, the orders of the angles should tell you all you need to know. All right, so there are lots of answers that you could have come up with. Say you started with R, then you went to P, and then you went to Q. So that means that you would have triangle RPQ is congruent to, so you started with the single angle mark. So that means we need to go to triangle J, then we will go to I, and then we'll go to H. So triangle JIH. And you can check any two letters to see if the segments line up. So then that would mean that segment RP should be congruent to segment JI, which is true. Then segment PQ is congruent to segment IH, which is also true. And finally, segment RQ would be congruent to segment JH. And all of those are true. So again, the congruency statement, just write the angles in the same order based on the number of markings. You could have also had RQP is congruent to, so RQP is going to be 3 and 2. So we would have JHI. So triangle RQP is congruent to triangle JHI. And that would be the same. Or you could have done triangle PRQ is congruent to triangle IJH. There are like 8 different answers to this. I'm sorry, there are 6 possibilities you could have run, not 8. There are 6 different answers you could have come up with. These are just 2 of them. The next example is us taking this a step farther and using some algebra to do this. So for what values of x and y make triangle MNO congruent to triangle PRT? So you pause the video and see what you can come up with. All right, so if we're solving this, we know that segment PR, according to our congruency statement, segment PR is congruent to segment MN. So that means that MN is 24. And if we're solving for, do we have enough information here? If we're solving for angle Y, angle T is congruent to angle O. So in this case, angle T is congruent to angle O. So that means that 3y is equal to 82.8 degrees. We divide both sides by 3. We're going to get y equals 82.8 divided by 3, which is 20. Let's see, 20. Let's see. Let me just get a calculator. I'm trying to do this math in my head. It should be 27.6, I think. 82.8 divided by 3 is 27.6. 27.6 degrees. All right, so y is 27.6, and now we need to find x. So according to our diagram, PR is congruent to MN. Why did I put ON over here? So that means that the 3x minus 9 should equal the 24. So 3x minus 9 equals 24. We add 9 to both sides, so we get 3x equals 33. Divide both sides by 3, and x is going to be 11. So y equals 27.6 and x equals 11 are the 2 values that make these triangles congruent. And again, we're using the congruency statement to justify our equations. And for the last example, we have triangle LMN is congruent to triangle PQR, and it's an isosceles triangle. So what measure of angle P can be used to prove that these triangles are congruent? So first, we need to find angle M or angle Q. So that's going to mean that 2x minus 26 equals x plus 16. And again, we know that because M is congruent to Q based on our congruency statement. So that means that if we solve for x, we get 2x minus 26. I'm sorry, I didn't even do anything. So we get 2x equals x plus 42. Subtract x from both sides, and we get x equals 42. So if x is 42, then 2 times 42, which is 84, minus 26 is going to be 58 degrees. So if this angle is 58, then angle, so we have 58 degrees. And remember, for an isosceles triangle, the base angles are congruent. So that means that if this is x, that angle is also x. We won't call it x since we already used the x. We'll use y instead. So that means that 58 plus 2y equals 180. Subtract 58 from both sides. We get 2y equals 180 minus 58 is 122. Divide both sides by 2, and we get y equals 61 degrees. All right. So that is going to conclude our video on parts of congruent triangles. So again, all of this is motivated by a congruency statement. And remember, a congruency statement tells what angles from one triangle are congruent to the angles of another triangle, and the ordering of the letters tells you which sides are congruent. So you like take the first two letters and they're congruent. That makes the same segment in the other triangle using the first two letters, the first and the third letter, and the last two letters. That's how you get your congruent segments. Thanks for watching.